Okay, this is basic function notation. If you've ever watched a math video, you don't watch it straight through. Listen to what the instructor says, and certain times I tell you, pause the video because I've got a problem I want you to try and then come back. It's like being in the classroom where the instructor gives you a problem for you to work on, and then, okay, now let's do it together. Same principle, except now it's done via video and you control the pausing and stopping. So let's first start out, what is function notation? Well, function notation looks like this. This is a very basic function. It's a linear function. And you may have seen equations before that look like this. Please understand, this and this is sort of the same thing. It's still on the y-axis. Okay? But this can give us flexibility on how we write things, because we can make these letters here mean something. I can, here I'm very limited. I can't tell, it's just y, just a letter. Where, let's say I'm talking about the function of revenue, well, then I would call it the R of X. If I want a profit function, that would be the P of X. Getting the idea? Where X is the quantity. So it makes for flexibility, and plus it gives us ability to tell people what the function actually represents. But for right now, we're going to give you just the basis of how to deal with functions. So over here on the right, if I wanted to tell you a number to plug in for X, I'd have to make a secondary comment like that. On the left, I wouldn't do that. I'd say F parentheses 2. Now, how is that pronounced? Well, this one, top one, is pronounced F of X. So guess what? The second one in red is F of 2. So the F of 2 is telling me that wherever I see an X, I plug in 2. That's simple. And then I crank the math. 3 times 2 is 6. 6 plus 4 is 10, but I write the answer, F of 2 equals 10. Here, I've got 2 different statements, and then I drop down, go 3 equals 3 times 2 plus 4, 6 plus 10, or I'm thinking ahead, 6 plus 4, which is 10, so y equals 10. I have to make double statements. All right. But function notation for right now, we're keeping it very simple to get you guys used to seeing it and manipulating it. It's understanding that whatever's in the parentheses is what we plug in for the X, no matter what it is. So let's do a couple. So I have F of X equals 2X minus 5. And I want to know the F of 1, F of negative 2, F of 2X. Let's throw a curveball a little bit. F of X plus 1. All right. So using what I just said, go ahead and pause the video, try it. Remember, whatever's in the parentheses is what you plug in for the X. So give it a shot, see what you get. All right. If you've done all 4, welcome back. If not, you just come through it. So the F of 1, Again, wherever I see an X, I put a parentheses and backfill with the number that's in the first parentheses. So I get 2 times 1 minus 5. Well, 2 times 1 is 2. Minus 5 equals -3. So the f of 1 equals -3. Here's 1. So next one, f of -2. Again, wherever I see an X, I put a parentheses and backfill with the number. 2 times -2 is what? -4. And the minus 5 drops. -4 minus 5 gives me -9. So f of -2 equals -9. Now, this next one's a little bit, students get confused on a little bit because they want to have a single answer like we've had on the first two. On the bottom two, all you're going to get is another equation. You're not getting rid of the x, you're adding to it. Put something with the x. So it's like in this case, I'm going to find 2x, but it's still the same procedure. Wherever I see an x, I put a parentheses and backfill with what was in this parentheses. So now 2 times 2x gives me 4x minus 5. 1 is a constant, 1 has a letter. They do not combine. So that is what f of 2x becomes. All right, so let's do this last one. It really is the same as before. Wherever the x is, I put a parentheses, backfill what was in my parentheses, first parentheses. Now, the difference is, this time I got to distribute. So 2 times x gives me 2x. 2 times 1 gives me 2. I'm going to combine like terms, though. If I get 2x, and 2 minus 5 gives me -3. So f of x plus 1 is 2x minus 3. All right? What do you think? Let's get a little bit more complex. And by the way, even though I'm using an f, f is the normal thing for a standard function. It could be a g of x, h of x, j of x. I could do j of p, use my initials. All right, this time I'm going to use a quadratic, which means I have more than one x to fill in for. So remember, again, what did I see originally? For every x I see in the equation, I'm going to fill in with what's in the required. So let's do a -1. Let's do a 3. Let's do 2x. And I really need to talk about this guy because you do have one in your homework. So at this point, pause it, see if you can do it. I look for most of you guys to stumble on that last one, but we'll see. All right, welcome back. So let's do f of -1. Wherever I see a parentheses, I'm backfilling with my -1. So -1 squared, be careful, it's +1. Because remember, what is an exponent? I wrote the wrong number. It means I take the number times itself that many times. So -1 squared means I take -1 times -1. Well, negative times a negative is a positive. Be careful if you key it into your calculator, unless you put the parentheses around it. A lot of your calculators will say the answer is -1. It's because it doesn't think the negative is being squared. It is. It's inside the parentheses with the number. So taking the exponent, I have 2 times 1. Everybody just drops. All right, now let's distribute. 2 times 1 is 2. -3 minus 1 is +3. -5 just drops. Well, 2 plus 3 is 5. And 5 minus 5 is 0. So f of -1 is 0. All right. I'm going to erase. And the next one is 3. Again, wherever I see an X, I plug in 3. Now I clean it up. 3 squared is 9, so I got 2 times 9. Now I'm going to go ahead and multiply that. -3 times 3 gives me -9. Now I need to multiply 2 times 9, which is 18. 18 minus 9 is 9. And 9 minus 5 is 4. So f of 3 equals 4. All right. You know, something different. Look at what I did. All right. Third one is a 2x. Wherever I seen the x, I plugged in 2x. 2x squared is the same as 2x times 2x, which gives me 4x squared. -3 times 2 gives me -6x. 2 times 4 gives me 8x squared minus 6x minus 5. Do I have any other like terms? The answer is no. So the answer is 8x squared minus 6x minus 5. Sorry, I'm kind of tight on room there. All right. Let's do this last one. Like we've been doing. Wherever I see the x, I plug in the h plus 3, h plus x. All right, oops, I see what I forgot. There was a squared on that parentheses. All right, how do you square a binomial? We're going to go more in depth in this, but sadly, not till a little later. Again, remember I said, what is an exponent? It means we take the number times itself. So 3 times 3 is the same as 3 squared. Well, what we're looking at is a parenthesis. So that just means nothing more than we take the parenthesis times itself. And I'm going to go ahead and distribute over here just to get it out of the way. Now, this is the method called FOIL, where I go the first to first. X times x is x squared. Outer, x times h gives me xh. Inner gives me xh. And last, h times h gives me h squared. Minus the 3x minus 3h minus 5. All that stuff's still carrying on. Now, for room reasons, xh plus xh equals 2xh. Now I'm going to distribute this 2. 2 times x squared gives me 2x squared. 2 times 2xh gives me 4xh. And 2 times h squared gives me 2h squared. The rest of it is outside the parentheses, so it is now tagging along. Except, or wrong letter. I look one last time. Is there any like terms? The answer is no. I have an x squared, but an x, xh, and no other xh's. I have an h squared, no others. I have just a plain h. A lot of times the pitfall is students will combine this to that and that to that. You can't do it. They're not identical. Remember your like terms. So this whole thing equals that. Right? This has been basic function notation.